Okay, our next method for finding a volume is called the washer method. And this is used when there is kind of a hole in the middle of something. It's like a washer has. So if you took, like for this example here, we're going to take the equation f of x is the square root of x. There's the red curve right there. And g of x is x squared. That's the green curve. We're going to find the area in between there. And then we're going to take that region and we're going to rotate it around the x-axis. And we're going to find the volume of that. So what you'll get is you'll get a solid that's kind of a bowl-shaped thing from the red, and then it's got this weird V-shaped thing cut out of it. And I wish I could draw these better on the dry erase, but it's just really tough to draw those. So what the washer method does, pretty much the same thing as the other method. We've got the volume is pi times the integral from a to b. Only this time we're going to take the outer radius, which is signified by the capital R, and then we're going to subtract the inner radius, which we're going to use a little r for that. That's going to be the green one in this case because it's on the inside. So when we set up this problem, the volume is going to be pi times the integral. Now, this problem's pretty simple to figure out that these things intersect at 0, 0, and 1, 1. But you could equate those things if it wasn't so easy. So we're going to integrate this from 0 to 1. And then we're going to take capital R of x is going to be squared, by the way, is going to be the square root of x squared. And we're going to take away the small one, which is going to be x squared dx. Okay. And then that's pretty simple to simplify here. We get pi times the integral from 0 to 1 of x minus x to the 4th dx. And that's a simple one to integrate. So that's going to be 1/2 x squared minus 1/5 x to the 5th. I'm going to evaluate that from 0 to 1. So the first thing we do is we plug in the 1. We get 1/2 times 1 squared is 1, so it's just 1/2 minus 1/5. Minus, if I plug zeros in there, I just get 0, so that's simple. Okay. And that ends up being 3/10. So volume equals 3 pi over 10 cubic units. Now you can use the same thing. You can integrate over you can use the same method if you integrate over the y's. If we were to rotate this thing around the y-axis, it would work the same way. So on this particular problem, if we were going to rotate it around the y-axis instead, we would integrate again from 0 to 1 because we're intersected here and here. Okay. And then we're going to use the capital R of x is going to be the green one this time because it's bigger along the x-axis. Okay, so that'd be x to the 4th minus x in this case. So we'd subtract the smaller one and we'd integrate the same way and we might get a different answer. Depends on the problem.